Hey, this is Mike from bookup.com. Alright, we've solved some problems in animation, so let's take a look at what we got in this episode of making the new Windows and Macintosh version. So, I got tired of having to open a new ebook every time I ran the program. So what I did was I short-circuited it. Let's show you what I did there. It's going to run really slowly since we're doing video. Bear with me. There we go. Scrolling up. So when the cow main form, in its form create, when the form is actually being created, in that particular method, what I did was when it was all done creating everything it needed to create, I had to do this. I had to create a new ebook window, which is the normal way. Just ask the ebook window class to create and make the parent the application, and then set its caption to the ebook, and then show it. And that's it. Just creates a new ebook window, and that's cool. So I didn't have to do that every time. So that was one thing that shortened my debug times because I kept having to run the program over and over and over to test the new animation stuff. So what else did I want to do? If you recall last time, we were trying to debug the drawing portion of the chess diagram. Let me switch over to the chess diagram code. There we go. So we really couldn't stop and debug step by step the drawing code because the timer continues to run even though we've stopped the program and are stepping through it. So the timer continues to ping our program, 10, 20 times a second going draw, draw, draw. So that's not a good way to do it, and there's really no elegant way to do it. So what I wanted to do is let it run and then maybe count how many times the draw frame procedure was being called. So that's what I did. So when I was all done, I wanted to be able to show it. So I needed a button. Let's go do that. Let's switch over to the ebook form and go to the design tab so we can see what the ebook form looks like. And you can see I've added a few new buttons here, like blank out the bitmap and copy things to screen and off screen. I used to debug all this stuff. Let's say I want a new button right in there. Let's go grab it. T button. There we go. Drop a button right about there. Stretch it out because we're going to call it Show Debug Info. And let's go change the text so it actually says that. Scroll down here to the text. Instead of just calling yourself button 2, we're going to say Show Debug Info. If I could type, info. There we go. So now it says that, Show Debug Info. And if we double click, we get access to the button 2 click handler, and we're going to do this. So we say, well, we know the F chess diagram is capable of doing things for us, but we want a public method called show debug info. Sure enough, there's already one there. I'm cheating. I've already written that puppy. So I put it in, and away we go. But what does show debug info do? Anytime this button's clicked and it goes and tells it to do that, let's go find out. Let's go copy this guy. Copy. There we go, because we're going to look for it in the other window. Copy it, and we look at chess diagram 2D, and let's find it. Show debug info, yes. Start from the start of the file, sure. Okay, first thing to notice here is we've got something surrounding these 5 debug procedures that I wrote. I actually called one debug blank out the self bitmap. And I called the next one, of course, Show Debug Info. Now what's surrounding them are these if-defs. Those are comments, so that's a left bracket comment. But that comment starts with a $sign, and the compiler will watch for this. So this is not Pascal code, but this is special stuff in Delphi saying if def, as in if defined this symbol, debug diagram, then include these procedures. Pretend like this is part of the code. And then $end if means end right there. So only if this thing debug diagram is actually there. Let's scroll to the top and see where I define that. Similarly, we have another command up here at the top of this unit where I just opened a comment and went $define, which is the command that Delphi is going to watch for in my comments. And if it sees that I defined this symbol called debug diagram, then it will include those headers for those other procedures. Now, why would I want to do this? Because when I actually ship this program, I'm going to delete this line or completely comment it out so the compiler cannot see it. And that means this symbol, debug diagram, will not be defined and those procedures will not be included in the actual shippable program, which will hopefully make it faster and less bloated. It won't take up as much memory because there's not as much code in there. That's the idea. It's only included if we're actually debugging. There's the procedure. So around the procedure itself, the method in this case, this procedure is a method of the type chess diagram 2D. I say if def debug diagram, then include the body of this procedure and the other debug ones down here too, like copy bitmap to off-screen bitmap, yada, yada, yada. So what happens in here is I'm using a Delphi procedure called message dialog. And message dialog is in all versions of Delphi. Basically, it allows us to do a quick and dirty message, a quick and dirty dialogue with whatever information we want to show. To do this, I actually use format strings. You don't have to do this, but I did because I want to make it look pretty. So format, and I give it this format. You can look up the format operator in your help file if you're interested in it. But I'm sending it the private little variable here called f number of animation frames rendered, and then a space, and then the actual words frames rendered period, and then a space. Over here I'm adding on a carriage return so that it goes to a new line rather than just making it strip across the screen. I'm making it go into the second line. So that's what that #13 is. That's a carriage return. And then I format the self bitmap height because the diagram on the screen that we're showing right now is 400, 500 pixels high. I want to see how big the actual bitmap is that we're scaling from. So that's what's going on. Let's run it and see what this thing does. I'll click on run. And it's going to take a while because, again, it moves very slowly while I'm recording video. I need a faster Mac. Oh well, there we go. And my shortcut ran, so the main window came up and it automatically threw out a new window behind me and has all the new stuff there. So I've got show debug info. If I click it now, it comes up and says, well, 0 frames rendered because I've not rendered anything. If I also, it's showing me that the height of the self bitmap and the off-screen bitmap I made are both the same size, and they're both 1300 pixels high. I was interested in how big the off-screen bitmap was because I modeled it after whatever the T-image component that we're making this chess diagram out of, how big its bitmap was. And it's going to be as high as it is wide. Chess diagrams are square. So 1300 pixels. So I can actually set the size here. I've got this little control. Let's see, maybe I'll set the size to, make it 200. So 200 pixels, oh no, not 2000, 200 pixels. Hit the right key there and click on my resize button. And it resizes to 200 pixels. Let's show the debug info again. It still shows the self bitmap of the image that it's showing is still 1300 high, and the off-screen matching at 1300 pixels high. So it's doing all kinds of scaling for us, which is really cool. Believe me, you do not want to have to write code that rasterizes and posterizes and basically shrinks things down to make them look beautiful, because that takes math, and nobody wants to do math if they don't have to. It's all built into the library. That T-image component is doing this for us. So that's good and okay. Let's change it back to like 450 or something. 450. There we go. Got to see my keyboard. And then resize. There we go. 450 and the offset of 30. So it's blanking out some of my buttons right now. Evidently the default was bigger than 30, so it's on top of some of my buttons. But who cares? Now we've got animate. It'll animate from whatever's on what square to whatever's on 2 squares. So what we're going to do is we're going to go to from square 0. That is where the white rook is on A1, and to square 77, which is the longest distance it can travel. So basically we're going to pick up this white rook from A1 and we're going to move it to H8. Not a legal chess move, but a good test animation because it's long. And if I click on animate, look at there, sure enough, it does the slowdown pixels, and when it gets to the end, it slows down a little bit too. If you notice, the slowdown's been turned on again too. So, like we talked about in the last lesson. So that it moved, how long did it take to do it? Show debug info, and it says there were 25 frames rendered from start to finish. That's cool, so now we know what was going on. It's actually calling and working, and you notice that it's actually working. Let's go find out what actually made it work, because last lesson you noticed we had trouble with the drawing of the frames in between. So in Chess Diagram 2D, there's somewhere in there a procedure that does do animation frame. That's it, because our animation timer, when it gets clicked, decides that if we're not animating, we're going to be animating. Maybe I should just hunt for it here. Let's click down on the search bar. Do animation frame. There we go. There it is. What I'm doing in do animation frame is I say again, if def debug diagram, the symbol that we declared up there, then we're going to include this little testing bit of code. We're going to increment the F number of animation frames rendered. And that's what's counting it. It's incrementing that. Every time it starts up the program or it starts an animation, it sets it to 0. Let's go check that out. So we copy this, and let's ask the search bar to find that. Restart from the beginning? Sure, because we're at the end of the file by now. Okay, so we're not even going to declare this variable unless, of course, it's defined debug diagram. And it's just going to be a regular old integer. Search for the next one. And when we start the program, this is in the end of the form create for this, whatever, the t-image create. And the last thing we do is we set the amount of frames rendered to 0. And then, of course, we're showing it inside the show debug info procedure. And then we set it to 0 every time we end, or every time we start a new animation. And here, we increment it every time we do an animation. Let's look at this guy. Yeah, .do animation. So there you go. So we've added some debug code. We've got some things fixed. Let's show what happened, or what actually got fixed here. All kinds of things we had to try. And I'll tell you right now, the documentation for Delphi XE4, at least as far as it goes to like doing core animation like this, is all wrong. I mean, really wrong. And I asked the experts in the forum for weeks about how to do it right, and I didn't get good answers. But between the few answers I got from the experts and some of the other code I got to look at that works in some other versions of Delphi, I finally figured out what needed to be there. What was probably missing was this call right there. The t-image has its own bitmap. Remember, this chess diagram is made out of a t-image. So we can say self, your bitmap, your canvas, which is an object that gets drawing inside of a bitmap, has to call begin screen. And if you don't do this, it just won't allow any drawing. You can draw all you want. Like, for instance, right here, I'm on this drawing a bitmap of source and rect. I'm drawing the off screen. It just wasn't working. And when I get all done drawing the piece that was dragged and everything, and then I end, well, if without that begin and end, it just didn't work. So there you go. You've seen the shortcuts we put in and the clever way we put debug code in, so we could ask it later on how many frames are actually drawn. And you see the sum of the fixes in code and all the different things I tried, self, end update, and canvas, end scene, and everything else, and tried to do the bitmap changed procedure. Some of these procedures exist and some of them don't because some of them were in the documentation and they are no longer there in FireMonkey. So it was a bit of a pain. Also, calling application process messages I thought was kind of critical at one point. It works in some places, but it doesn't work here. And the new version of that is actually called application.handle messages, and that took some research to figure out too. So I wish the documentation were a lot better, but it's not. But don't worry, I think we've gotten over the most interesting technical hurdle in this entire project. So I'll see you on the other side. Well, let's try one more thing. Before we do that, let's go over here and switch to Macintosh. Make sure this guy works in Macintosh. So I switched my target to OS X32 from Win32. And come back over here and run it. And let's watch this puppy pop up on the Macintosh side. Make sure it actually animates a piece. If it does, we could be golden. While that's linking and running, I'll tell you the next thing we're up to is dragging pieces, because once you can drag a piece and put it in, that's pretty much all you need a diagram to do. Everything else is candy, like drawing dots and arrows and that kind of thing. And making it go faster, of course, and doing some optimizations to eliminate flicker. Okay, still deploying. All right. Wait for it to come up. There we go. All right, we're looking at a Macintosh version. Woo! Let's scroll it down here so you can see it. All right, very similar buttons. Obviously a Macintosh window with Macintosh controls and Macintosh styling. And we want to go from square 0. And maybe move that up again to square 77. And animate. And slow start. And again, it's going really, really slow because, well, I'm using a Macintosh to run Windows, which is running Delphi, which is creating a Macintosh program thrown back on the Macintosh side to run on the Macintosh while I'm recording video. I'm surprised this thing is running at all. So let's click Show Debug Info and see what it did. There enough. It says 25 frames are rendered for the same movement that we saw on the Windows side, except a little bit slower. It reports the same size for the self bitmap and the off-screen bitmap that I made. So there you go. We've got code running and animating chess pieces, which I swear if I weren't doing video would run a lot faster. They really do. Trust me on that. And it seems to be running well. Next up is dragging pieces around. So I'll see you in the next lesson. Thanks for watching.